Welcome back to the series of NLP lecture series. So, in the earlier sessions, we have seen the basics of language NLP, the language models, applications of NLP, word representations, various text pre-processing steps, NLP pipeline, and all word embeddings discussion. Now, in this session, we'll be having a light throwing on distributional similarity and distributional hypothesis. How we can illustrate how the various terms or the words are being similar in this context as well as dissimilar in the hypothesis space. So, for that, let us start the session. So, earlier sessions, as we have seen in the earlier video lectures, the coming to the basic pre-processing, the pipeline, the text representations, how we are converting the text into word vectors, the TF IDF, the usage of bag of words, bag of n-grams, each is having its own feature as well as the advantage and limitation of how we can use them accordingly. We also have some two terms called as distributional similarity, distributional hypothesis of how the words are going to be similar and dissimilar based on their context and based on their scenario where we are going to use. So, in this short video lecture, we are going to see what it is about, how we can use it in the different context, and how the context matters a more weightage in NLP pre-processing or the processing applications. So the basic idea of what it is that the distributional similarity is that how are we going to measure the similarity, the semantic similarity between the words and all. So it is based upon the context where it is available. So in short, I can say that the word is known by the company of it where it is being resided. So we have two kinds of basic definitions here as connotation and denotation. Connotation means where it is about the meaning which is depending upon the context, and the denotation means which is a literal meaning of the word. For example, I have a sentence called as NLP rocks. The actual meaning, the literal meaning of the rocks is actually stone and all. But if I am going to use in the context scenario of NLP and rocks, means that it is I'm appreciating there is something good, something fashionable about the NLP which I am talking it that it's very good enough. So this is what the context matters. So here it is being used as the connotation similarity, where we are using the word rocks to tell that the NLP is good enough. Similarly, we also have the word fire, where the actual meaning is flame and all. But if I am going to use in context that movie was fire and all, means it is very excellent. So the connotation term, the context meaning is excellent or exciting. Similarly, we have she cracked the exam. Denotation term is where we are having the crack is nothing but actual meaning is to break off. But when we are writing with the context, she cracked the exam, it is connotation. So it is to succeed. Similarly, the phone is switch off, the phone is sick. I am sick of the movie. Yes, he is bright student. Bright means it's actually full of light. But in the context, the connotation meaning is about intelligent, bright enough, very good enough and all. So likewise, we also have this are the words which are being talked with respect to the words context. We also have some kind of the mapping with respect to the hypothesis space, where two or more different words are being talked in a similar scenario or the similar space context. Here it was the usage of the word is being used differently because of the occurrence of in and around the words. Here we have distributional hypothesis which illustrates the word appears in the similar context, which tend to have similar meanings, though they are not belonging to the same literal meanings. Or example, the most occurred in the frequent regular usage language is dog and cat. These English words or generally appear in the similar context, which belong to the category of pet animals. Though we have some other animals like horse, duck, and all. But still, we are more emphasize more usage of the in the daily hypothesis or the similar space context is what is dog and cat. So, according to distributional hypothesis, there should be some strong similarity of usage where the word is being addressed and the cat word is being addressed. So, thus, if two words often occur in some similar context space, then those corresponding representation vectors should also be coming to close to each other. That concept we call it as distributional hypothesis. Let us also see some examples now. Dog and cat, which I have mentioned just now, where dog, pet, all the cat animals are already appear in the similar space contextual scenario. Similarly, we have car and bike. Though we have other means of transport, still people are more tuned to use the common term as car and bike. Though I have other means of transport. So the similar here, car and bike are being mapped in a similar space context. Yes, next is teacher and profession, which is being mapped in a similar space context of educators, where teacher might be teaching to the other audience, whereas the professor may be giving the lectures and on in some other audience. But still, we belong to the same scenario of the meaning term as educator. Similarly, happy and joy. Most people use happy, sometimes joy, sometimes joyful and all, but still they belong to the same scenario of the emotion concept. Similarly, you have phone and laptop. Though I have so many other means of usage of the gadgets, but still most of the things we talk about is phone and laptop. We do not use any other uh, uh, words and all. So all these dog, cat, bike and teacher, professor, happy, joy all belong to the same scenario space. That concept we call it as distributional hypothesis. So the next is, what is the use of this distributional hypothesis or the distribution similarity, how we are going to map these phrases and all. Not only performing the word embeddings, we can also do phrase embeddings, we can also do some sentence mapping also being used, we can also do some two or more words which can be mapped in the same space context or in the same usage of the more or less same. This distributional similarities will try to highlight or will be used to set the context, whether we do the CBOW, whether we do skipgram or the word to wake or any embeddings and all. But the basic agenda is that the words are being represented in the form of co-occurrence with respect to the number of times it is being represented, and also the number of similarity words which are being differentiated and their vectors. Yes, so the each word W in a vector form is being represented as W1, W1, which is belongs to this space in n-dimensional vector space, and each element is going to capture the degree to which that particular word is associated with some other context. In this example, the dog and cat was being associated with some similar context space as pet animals. Yes, so we can also see some examples now. And these distributional similarities are helpful in providing the vector space semantics and also in easing the process of word sense disambiguous. Word sense disambiguous means which is used to try to determine the occurrence of the particular word to tell to which context it is belong. So we have to determine the similarity of the words. Vice versa, we can also determine the dissimilarity between the words and all. Yes, so this dissimilarity context are used for to specify the vector space semantics and word sets disambiguance. One more example to have here. These distributional similarities not only provide this but also helpful in providing the dense vectors in TF, IDF, bag of words, or the traditional word representation or text representations. We are going to have the usage of space vectors where each dimension or each word is being represented in different forms of binary vectors of zeros and ones. And also you have a chance that more number of the zeros are being repeated, and when the space or when the data samples are being increased, it is difficult for us to manage the sparse vectors. That's how we have the dense vector representations, where we can represent the more the what do you say, the singular value decomposition, the orthogonal representation of the vector of these words can be mapped in terms of the vectors, the huge dense vectors, either by using LSA or by using some SVD concepts. Here we could see the analogy that the man minus the king minus vector of king and minus the vector of man, and then if we are going to add the vector of woman, it results nothing but to queen vector. Similarly, we have the vector of Paris minus vector of France plus Italy is equals to the vector of Rome. So all these are being mapped, and we can do some mathematical vector operations because of this dense representation of these dense vectors. This all is possible because of the context and also because of the co-occurrences of how these man and woman are being mapped in the space. So what does this context give the preference in this word embeddings, or making our text processing applications, or running the text classification models, or applying any NLP problem and all? So this context will try to give us the scenario, tell us about how the word is being appeared in, what is the weightage of that context which is being talked about. I will just show you an example here. We have some two left and right, which is having some sample corpus. To the right side, we have it in English form, which is talked about a wine or a beer discussion. Similarly, we also have in the left a bottle of, which is being written in some non-understandable English, where we don't know what is the actual word meaning of test or tesuino, which is being placed on the table. Everybody likes dash, and tesuino makes you drunk. We make tesuino out of the corn. Like, well, we have some statement, though we don't know the exact meaning of tesuino, but still, probably we can understand that these sentences are being talked about some alcoholic drink which is being kept on the table, and people like about it, and they have, and also makes you to feel to addict about it and all. So we can automatically identify that this is nothing but about the beer discussion. The same context which is being here written in the white English English sentence form. So we can say that, we can assume that in this context, though the probable word wine or beer is not being talked or is not being addressed in English sentence word, still I can predict, I can determine the occurrence of this Tesgoin word. This is how the context is going to give weightage for the NLP model to talk about how it is being used. And similarly, we also have plant. Whenever I say plant, which I am talking about the plant in the context of garden and all, it is nothing but which is having the leaves, the greenery part and all. And also when I talk in terms of the factories and all, even the factory is also called as one of the plant. Similarly, we have the bank. When I talk in the scenario of the transactions and all, it becomes my physical bank where I have the transactions. When I talk about the reverse side and applications, again it is different. Okay, so more or less I can determine based upon my house is near to reverse side of bank available, means I can easily determine that this is okay related to the reverse side bank. Yes, I went to bank to perform some transactions, means again that is different. So likewise, we can automatically try to illustrate how these words are being used in different context. And also we have some examples where I'm having some available list of 2 or 7 or 6 words which is talked about the lemon, some pineapple, computer information. So in the word to word matrix, you could see that the words are being mapped based on their availability. Suppose an apricot, which is related to the sugar content, and a pinch of maybe I cannot map it to computer or map it to the result. Similarly, I have the word information, which is being mapped to the computer terms as well as to the data where we have more usage. Maybe I cannot map it to the pinch of salt or sugar and all. So likewise, first we can write a function of mapping between the words with respect to the context. So these are the word to word mapping with respect to the context of the usage of the terms, which I have some sample of sentences as cautiously she sampled her first, well suited to programming, digital, likewise purpose of gathering data and information. Now automatically the next sentence may be which is from the above things. So likewise, from this word to word matrix, we can see that now we in the context of see how many times that word is being appeared. If it is appearing in that context, it is yes. If it is not appearing, that it is no. So likewise, if the apricot is being which is being boiled and all being converted into some other recipe, then you have one, and it is maybe large, maybe it's having a sugar content. I need some water to boil, so it is available, then I have yes. Similarly, for the information, maybe for data it is yes, for function it is yes, for computers it is yes, and so on, may not be for the others. Now we can also determine how many times these co-occurrences of these binary words have been appeared in that particular context. It is 0 times, n times, or so on. In this example, we can see that the word information in this context of discussion about some computer terminology and all, it has been used with respect to data for 35 times. Similarly, the word digital have been talked about 31 times. Similarly, it is being discussed with respect to the function for 23 times. Base I'm writing some function, C function, or some mathematical function, writing some illustrating, running it, and so on. And the same words pineapple is being talked about more times whenever I'm talking in the digital large, and sugar 8 times, and so on. The digital has been discussed more in large. So likewise, we can also count it and then determine the probability of the occurrence of the word with respect to context. So for this, we have this formula, function of the wi with respect to that context and then summing it up. Yes, so in this example, suppose I have the word information 1 plus 6 plus 4. It is totally 6 plus 4, 10, 10 plus 1, 11. So it is 11 by 19. The probability of the word occurrence of information out of the total available words. This total is 19. So the probability is it is 11 by 19. Similarly, the probability of occurrence of the word data, yes, of the word data with respect to the all total number of available words. It is 6 plus 1, it is 7 by 19. Similarly, if I want to infer the occurrence of the word of information with respect to context, data, it is 6 by 9. It is 6 by 9 where I am talking about the information with respect to data. So you could see this. This is the 6 by 9. It is point. Likewise, we can note down the probabilities of each words, which is here it is 0.58, here it is 0.32, yes, and here it is 0.37, likewise, and then make some dense vectors, and then would be helpful for our detailed NLP models or for the deep learning or any analyzing the process. So to keep it wrapping up, so today we have discussed what does it mean by connotation, denotation, where denotation and connotation is talked about with respect to the context, and this is with literal meaning, and these are helpful in in analyzing the occurrences of or the probability of to determine the probability of occurrence of the word with respect to context. Yes, thank you. In the next session, we'll be seeing about the bird models, the bird types, and one small example for the bird, how to determine the NER with the bird usage. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.